Section 4.1 talks about probability distributions. So we're going to talk about a couple things called random variables. And it says an outcome of a probability experiment, such as rolling a die, is often a count or a measure. So a random variable x represents a numerical value associated with each outcome of a probability experiment. It says a random variable is discrete when it has a finite or countable number of possible outcomes that can be listed. A random variable is continuous when it has an uncountable number of possible outcomes represented by an interval on a number line. Okay, so it says, the first question here says, determine whether the random variable x is discrete or continuous. And it says, let x represent the number of books in a library. So we could all go down to our public library, whether you live in Edinburgh, McAllen, Mission, La Villa, whatever it happens to be, right? Mercedes. And if I go down to the Mercedes Public Library, and I could sit there, right? Or I could walk down each of the aisles and I could count all the books that they have, right? And I'd probably need a little clicker to keep track of everything, but at the end I would have a number, right? And that number would be, would be discrete, right? So say I came up with 1,876,349 books, right? So that would be a discrete number, right? Because I can count it, right? Now it says, let x represent the distance a baseball travels after being hit. Now a baseball traveling, guys, is measured kind of like on a number line. You know what I mean? It would be something like this. And this would be continuous because that distance, you can't necessarily count, like you might say, oh, it traveled 3 feet or whatever, or 18.9 feet or whatever, but it's going to be continuous because there are not countable measurements, okay? So now it says, identify whether you're dealing with a discrete or continuous random variable helps determine what statistical techniques are used to analyze each. So in dealing with discrete probability distributions, which is what we're going to be talking about right now, it says each value of a discrete random variable can be assigned a probability. This forms a discrete probability distribution. And it says the discrete probability distribution lists each possible value the random variable can assume together with its probability, and that we have to satisfy the following conditions. So it says the probability of each value is going to be between 0 and 1, including 0 and including 1. If we take all the probabilities and add them together, that's what the sum means, right? Sum means to add. If we take all the probabilities and add them together, we should get 1. Okay? So it says, how do we construct a discrete probability distribution? We're going to let x be a discrete random variable with possible outcomes, x1, x2, however many we're going to have, right? We're going to make a frequency distribution for the possible outcomes. We're going to find the sum of the frequencies. We're going to find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. I'll explain what this piece means. Oops. Oh, come on, my pen froze again. I'll explain what that part means in a minute. Let me see if I can get my pen to work. There we go. And we're going to make sure that the probability is between 0 and 1 and that the sum is 1. Okay. So here's my first problem, and it says, a company tracks the number of sales new employees make each day during a 100-day probationary period. The results for one new employee are shown. Construct and graph a probability distribution. Okay, so if I look at this table here, let's look what this table is telling me. The first column here is telling me, why does my pen keep freezing? The first column here is telling me the number of sales per day, okay? So if I look at that first one, 0 sales. How many days did this person make 0 sales? 16 out of those 100 days, this salesperson made 0 sales. They made 1 sale out of 19 out of those 100. They made 2 sales out of 15 of those 100 days, so on and so forth, okay? So the first thing I'm going to do here is we're going to find the sum of the days, right? Number of days. Well, we already know how many days it is, right? It's 100. So we could take our calculator and we could add 16 and 19 and 15 and all that kind of stuff. But we add them up, we should get 100 because it's 100 days. Okay. And so now what I'm going to do is I'm going to make a little table. So 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now we're going to find the probability. So the way we find the probability is I'm going to take each of these numbers and I'm going to divide them by 100. Okay. So if I take each of these numbers here and divide them by 100 and then write them as a decimal, for the first one, because I'm dividing by 100, it's going to be 0.16, 0.19, 0.15, 0.21, 0.9, 0.10, 0.08, and 0.02. Okay? So we have done the first part, which is to construct our probability distribution. Now, it also wants us to do a graph. Okay? Now, it's been a little while since we did this. We did this back in chapter 2, but I'm going to do a little graph, okay? And my graph is going to look something like this. So give me 1 second. Let me put little marks here and do this part. So I'm going to make little marks. Okay. And I'm going to make little bars. So right here I'm going to put 0 and 1 and 2 and 3, 4, 5, 6, and 7. Okay. And I'm going to go on my vertical axis, I'm going to go like 0.05, 0.10, 0.15. That doesn't look like a nice 15, does it? You can do a little better than that. And maybe one more here at 0.20. Okay. And let's take a look. So at 0, we had 0.16. So it's just right above 16 or 15. I'm sorry. So I'm going to go like this. Oops. Make this bar a little bit better. At 1, I had 0.19, which is, oh, come on, pen. I don't know what's going on with this pen, guys. Sorry about that. Give me 1 second. Let me try something. All right, let's see. There we go. Okay, so at 1, I'm going to go up to 0.19, which is just right above, or right below 20. At 2, I'm going to go to 0.15. At 3, I'm going to go to 0.21, so it's going to be a little slightly higher. At 4, 0.9, which is just right underneath 10. At 5, it's right at 0.10. At 6, it's just a little slightly lower at 0.8 or 0.08. And at 7, ooh, it's barely at 0.02. So we have kind of like a histogram. What we have here in the middle, guys, these are kind of like my midpoints, right? Right here. Okay. So now let's see if we can figure out part A. Part A says find the probability that 5 or 6 cars were sold. So we're going to find the probability that 5 or 6 cars were sold. So we're going to take the probability that 5 cars were sold, and we're going to add the probability that 6 cars were sold. So at 5, it's 0.10, and at 6, it's 0.08. So that would leave me with 0.18. Okay. Now, part B says, find the probability that 4 or more cars were sold. Okay. 4 or more cars would be X is bigger than or equal to 4. So I'm going to take 4, 5, 6, and 7, and I'm going to add those numbers up. So we have, oops, this was a 0.09, I'm sorry. I put 0.9 right here, but that should have been 0.09. Okay. So I'm going to take 0.09 plus 0.10 plus 0.08 plus 0.02. Okay. I'm going to grab my calculator real quick so I can add those numbers together. Let me move this over, turn it on, clear it out. Okay, so I have 0.09 plus 0.10 plus 0.08 plus 0.02, and I'm coming up with 0.29. Okay. Okay. Part C says, find the probability that the number of cars sold was between 5 and 3. And if you notice here, there's the word inclusive. Okay. So what they mean by that is that I'm going to look at 3 and 5, including 3 and 5. So I'm going to look at this one, and this one. Okay. So for 3, it's 0.21. For 4, it's 0.09. And for 5, it's 0.10. And again, we're going to take those numbers and add them up. So 0.21 plus 0.09, 9 plus 0.10 equals 0.4. Okay. And part D says, find the probability that at most 3 cars were sold. Okay, so at most 3 cars. At most 3 cars means that X is going to be smaller than or equal to 3 at most, so no more than 3. So I'm going to look at these here. Okay, so I'll start off at 0, which is 0.16, 0.19, 0.15, and 0.21. Okay. And again, let me grab my calculator and add those numbers together. 0.16 plus 0.19 plus 0.15 plus 0.21 equals, okay, so 0.71. Okay. And so we got the answers for our first 4 parts of that one question, right? Okay, so now let's see if we can figure out the next piece here. And it says, determine the required value of the missing probability to make the distribution a discrete probability distribution. Okay, so remember what we said. Every one of these numbers here, guys, has to be a number between 0 and 1. And if we were to take all the probabilities here and we were to add them up, we should come up with the number 1. So if I'm trying to find this middle piece here, what I'm going to do is I'm going to add these 3 together. Okay. So let me clear that out. Let's start out 0.21, because that's the first one we got, plus 0.43, plus 0.12. And if we know that everything here has to add up to 1, if I want to find that missing value, I'm going to say, well, what's 1 minus 0.76, or my answer? And so this piece here needs to be a 0.24. Okay. All right. So now let's take a look at the next question here. There's 3 parts to it, and it says determine whether the distribution is a discrete probability distribution. Okay. So again, first thing I'm going to do these numbers here, number 1, they're all between 0 and 1. That's perfect. Number 2, I want to know, do they add up to 1? So let me move this over. Let's start 0.10 plus 0.20 plus 0.30 plus 0.20 again plus 0.10. And did I miss anything? Let me make sure I got them all. 10, 20, 30, 20, and 10. It looks like they do not, because they only add up to 0.9. So not a probability distribution, right? Okay, this one here, I'm also going to say not a probability distribution. Remember, all the numbers have to be between 0 and 1. That one there, my friends, is negative, right? Okay, so let me check the third one here. Let's see, 0.09 plus 0.21 plus 0.40 plus 0.21 again plus another 0.09, and we come up to 1. So yes, that one is a discrete probability distribution. Okay. All right. So we're going to talk about finding the mean, the variance, and the standard deviation. So it says the mean of a discrete random variable is given by, and it gives me a little table here, right? And it says each value of x is multiplied by the corresponding probability and the products are added. This is useful when you're given a probability distribution or one that can be easily created. All right, so it's asking us to find the mean of the probability distribution in the problem that we did earlier. Okay, so let's go ahead and do that. So let me come back here. And so what I'm going to do, guys, I'm going to copy this piece here over into, where did it go? Here we go, into this table here, okay? So I'm going to pause the video so I can do that, and when I come back, I'll be in here written for us. Okay, so I copied all those numbers down there for us, so here they are. And so now the next thing I'm going to do, I want you to look at this piece here. We're going to multiply. So 0 times 0.16, oh, I know that's 0. 1 times 0.19, oh, I know that's 0.19. 2 times 0.15, 0.30. 3 times 0.21, 0.63. Okay. 4 times 0.09 should be 0.36. Let's see, 5 times 0.10 is 0.50. 6 times 0.08 is 0.48. And 7 times 0.02 is a 0.14. Okay. Now what I'm going to do now, guys, remember what this symbol means? That little funny looking E means we're going to find the sum. We're going to add them together. Okie dokie artichoke. Let me grab my calculator again. Clear it out. So we can add 0. Plus 0.19 plus 0.30 plus 0.63 plus 0.36 plus 0.50 plus 0.48 plus 0.14, and I am coming up with 2.6. Okay, so let me write that down here. 2.6. Okay, what we found was the mean, right? Remember how we use the mean? We usually use x bar, 2.6. Okay, so what this means is on average, in those 100 days, if you were to pick on average how many cars were sold per day, about 2.6 cars were sold. Okay. Now, for the next part here, we have how do we find the variance and the standard deviation, right? So we're going to figure out how do we find the variance and standard deviation. And guys, instead of having to do all these calculations right here, I'm going to try to make this a little bit easier, breezier, cover girl by doing this on the calculator for us, okay? So first thing I'm going to do, I'm going to pull up my calculator. I'm going to clear it out. I'm going to go to stat. Remember, if I was using my app, I would do exactly the same thing. It's just I don't have my app uploaded on my laptop here, so I'm using this. Okay, my list one, I'm going to put in the numbers 0 through 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay, enter. Then I'm going to scroll all the way to the top. I'm going to go to list 2. Okay, list 2. First thing I'm going to do, 0.16. Okay, 0.16, enter. 0.19, enter. 0.15, enter. 0.21, enter. 0.09, enter. 0.10, 0.08, and 0.02. Okay, so now I have two lists, right? List 1 and list 2. I'm going to come back to stat. I'm going to go ahead and go to calculate. I'm going to calculate my one variable stats. Now, again, if I'm doing this on my app, notice my parentheses normally pops up, right? So I'm going to go L1, and then I'm going to hit the comma button. The comma button looks like it's right above my number 7. And I'm going to hit second and the number 2 so I can get list 2. So I'm going to do L1, comma L2, close my parentheses, hit enter. And I want you to notice a couple of things. Up here, do you see where it says X bar is 2.6? That's what we found earlier, right? We did it the long way earlier, the first time, but now I know, or now you all know, hey, look, I can do this using my calculator. I don't necessarily have to make this table each time. Guys, the reason I made the table, I wanted you to see the process and how it's done, but your calculator or that Graph and Calc 83 app is doing that calculation for you, right? But just so you know, this is where it came from. All right, we're going to find our standard deviation. Here's my standard deviation. So in the problems we've been doing, usually standard deviation is asking me to go to one decimal place. So my standard deviation would be 1.9. So my standard deviation here would be 1.9. And then my variance is going to be my standard deviation squared, right? So all I'm going to do is come back to my calculator. I'm going to clear that. I'm going to type in 1.9. I'm going to square it. And I'm coming up with 3.61. So my variance is 3.61. Okay? And my standard deviation is 1.9. Okay, now let's see if we can have an understanding of what does this mean. Okay? So remember what we said? We said on average, we sold 2.6 cars per day. The standard deviation tells me if this is 1.9, think of it, if we were to round kind of like to the nearest whole number, think about it as 2, okay? So we sold 2.6 cars per day. With most of the days, we sold 2.6, and sometimes we had 2 cars more or 2 cars less. The standard deviation, remember when we did this kind of our empirical curve here, right? So my X bar here would have been 2.6. And then this would have been 2.6 plus another 2, so this would be 4.6. If we subtracted another 2, that'd be about 0.6 right there. So most of the cars that were sold per day happen to either be between 0.6 of a car, which you really can't sell 0.6 of a car, right? Or up to 4.6. So either we sold not too many cars or up to about 4, maybe 5 cars per day, right? Because of that standard deviation. That standard deviation is the spread here and the spread here. So it's kind of like a little tolerance, like a plus minus type business, right? Okie dokie. So again, this here, I mean, we could have done this calculation wise, but guys, this would be very, very time consuming to do, right? I'm going to make the same list that I had before. I'm going to subtract from the 2.6. I'm going to square those numbers. I'm going to multiply them each by their probability. I'm going to have to add them all up. And it's pretty time consuming. It's pretty messy, right? So that's one of the nice things about using the calculator. All right. Now we have something called the expected value. Let's talk a little bit about expected value. It says the mean of a random variable represents what you would expect to happen over thousands of trials and is known as the expected value. So the expected value of a discrete random variable is equal to the mean of the random variable. All right. So look, I'm going to kind of walk you through the process and see what's going on here. It says at a raffle, 2,000 tickets are sold for $5 each. For 5 prizes of $2,000, $1,000, $500, $250, and $100. You buy 1 ticket. What is the expected value of your game? Okay, so let's see if we can't figure this part out. All right, so it says here, to begin, figure your gain from each prize. It says if you win $2,000, you only gain $19.95. Okay, so the first question might be, why am I going to, if I win 2,000, why am I only gaining 19.95? Because we had to buy that ticket for how much? For $5, right? So if I pay $5 for my raffle ticket and I win the $2,000 prize, I really only won, $1,995, right? Okay, so that's the one for the first one. If I won $1,000, I would really only gain $995. If I won $500, I'd really only gain $495. If I won $250, I would really gain $245. And if I were to win 100, I would really win 95. And if I lost my $5. That's why it's negative. Okay. So the next thing we're going to figure out is how many tickets were sold? 2,000, right? Okay, so there's one prize at $2,000. So the probability that I get that ticket is 1 out of 2,000. And there's one prize at $1,000, and the probability that I win that ticket is also 1 out of 2,000. And it's going to be the same for these here, right? So 1 out of 2,000, 1 out of 2,000, 1 out of 2,000, okay? So now I need to figure out what's the probability that I'm going to lose. So how many prizes are there? There's 5 prizes. So notice 1, 2, 3, 4, 5. There's 5, in essence, there's 5 winning tickets. So if there's 5 winning tickets out of the 2,000, how many tickets do not win? 1995 don't win, right? So 1995 out of the 2,000 don't win, okay? Now what we're going to do, we're going to multiply straight across. So I'm going to write this as 1995 over 2,000, 995 out of 2,000, 495 out of 2,000, 245 out of 2,000, 95 out of 2,000, and I got to multiply here because the other ones were 1, it was easy to do. So now I got to figure out, turn it on, what's a negative 5 times 1995? Oops. 95, it is negative 9975. Negative 9975 out of 2,000, okay? And notice what we're going to do. We're going to add them all up, okay? So I'll give you a hint. The denominator is 2,000. So all I'm going to do is I'm going to go like this. 1995 plus 995 plus 495 plus 245 plus 95 minus 9975. Let me do that on my calculator. Okay. So 1995, oops, 95 plus 995 plus 495 plus 245 plus 95 minus 9975 equals negative 6150 over 2,000. So one more time, we're going to divide it by 2,000, and negative 3.075. If I were to think about this in terms of money, because this is money, right? We're talking about raffle tickets here. Okay. What this means is if I keep playing this game, and suppose this is a raffle that's done every day for 10 years, and I do this every day for 10 years, there's going to be days that I'm going to win money. There's going to be days that I'm going to lose money, because you can see that there's, out of the 2,000 tickets, 1,995 are losing tickets. But there's going to be days that I'm going to get lucky. But what this would mean, if I were to do this, say, every day for, 5 years, 10 years, 3 years, whatever you want to say, on average, each time I played this, I lost $3.08. Okay? All right. So I have another couple more probability distribution problems because I want us to make sure that we're comfortable with these here. And we'll see if we can't figure them out. Okay, so it says to construct a probability distribution. So we have overtime hours, the number of overtime hours worked in 1 week per employee. So we have our overtime hours and we have our employees. So the first thing we're going to do, we're going to go ahead and make our probability distribution. Okay. So the first thing I'm going to do, guys, I'm going to make a real kind of big table here just because I write kind of big. It's hard for me to write small. I got big hands. 1, 2, 3, 4, 5, and 6. Okay, the first thing I need to do, I need to take these numbers here and add them all up. And I did that right now, and I came up with 192. Okay? And so then the next thing I'm going to do, guys, let me grab my calculator here. Let me turn it on. Clear that out. The next thing I'm going to do, I'm going to take each of those numbers, 6, 12, 29, 57. I'm going to divide them all by 192. So like, what's 6 divided by 192? And I'm coming up with 0.03125. 0.03125. Okay, so I'm going to pause the video and I'm going to do the same thing for the rest of those. We're going to pause the video, do the same thing for the rest of the numbers, and then figure out what we're going to get. Okay, so just to give you a heads up, the next one, I'll do the next one right now just so you can see what I'm doing. 12 divided by 192, 0.0625. So that's going to be the next number that I'm going to put in right here, 0.0625. Again, if you're wondering where did I get the 192, I added those numbers up, okay? So let me pause the video and I'll keep doing that. Okay, so filled out my table, right? Got all my decimals. And now part A says, find the probability whose overtime hours is 1 or 2 hours. So 1 or 2 will be the probability of 1 plus the probability of 2. So I'm going to take my calculator, 0.03125, plus for 2, it's 0.0625. And I'm just going to add those numbers together. Let me get my calculator here. Let me clear this. 0.03125 plus 0.0625. And I'm coming up with 0.09375. Okay. 2 or less. So 2 or less would be 0, 1, or 2. So probability that x is smaller than or equal to 2. So I'm going to take, again, 0.03125 plus 0.0625 plus 0.1510. So if you notice, we've already added those numbers together in the first part. So now we can just add 0.1510. And I'm coming up with 0.24475. 0.24475. Okay. All right. It says, the next part says between 3 and 6 inclusive. So I want these here, 3, 4, 5, and 6. Okay. So that x is going to be between 3 and 6. So I'm going to take 0.2969 plus 0.21875 plus 0.15625 plus 0.0833, and I'm going to add those numbers up together. Okay, 0.2969 plus 0.21875 plus 0.15625 plus 0.0833. Enter, and I'm coming up with 0.7552. Okay. And then it says between 1 and 3 hours inclusive. Between 1 and 3 hours inclusive would be those there. So 0.0625 plus 0.1510 and plus 0.2969. Okay. So let's take a look-see here. Let me grab my calculator again. 0.0625 plus 0.1510 plus 0.2969. And I'm coming up with 0.5104. Okay. And then it says at most 4 hours. So what do we think at most 4 hours means, right? At most 4 hours means 4 hours or less. So it's going to be those 4 right there, okay? So if you notice on the problem that we just did these three right here, right? So if I take these two numbers and add it to this, then I'll have my answer, right? So let's add those two numbers. So 0.03125 plus 0.21875, and I'm coming up with 0.7604. Oops. 0.7604. Okay. So guys, one thing I want to mention is obviously this is a lot of calculator work, right? So take your time when you're doing this part of the table right here. You want to take your time with this piece just because any small miscalculation is going to throw off all your answers, right? So just when you're doing it, be careful. Make sure you're doing okay. Let's see. So let's see if we can find this next part here. And it says, find the mean, variance, and standard deviation of the probability distribution. So it says baseball, the number of games played in each World Series from 1903 to 2016. Okay. So let's see. We're going to make a table. Let me grab my calculator again. I'm going to move it over here to the side. I'm going to clear it. I'm going to go to stat. I'm going to edit my lists. And I want to clear both those lists. I'm going to hit clear on list 2, enter. I'm going to go up to list 1. I'm going to clear that one as well. Oops, clear it. Clear, and then enter. There we go. Okay, so for my list 1, I'm going to type in the numbers 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. And then for my list 2, I'm going to type in 0.188 for my first one, 88. 0.223, 0.214, 0.348, 0.027. Okay, enter. And now what I'm going to do, I'm going to go to stat again. I'm going to calculate my one variable stats. Okay, I'm going to open up my parentheses. Again, on your app, that'll already be there, right? You're going to hit L1, comma, L2. Okay, we're going to hit enter. All right, so we're going to find the mean. Remember what the mean is, X bar, right? That's the average. So X bar was about 5.8. Okay, so World Series, usually most number of games they're going to have is 9. Okay, it says on average, if we were to take all the World Series from 1903 to 2016, all the World Series, all the games on average lasted about 5.8, right? So I might say, this is about 6 games, right? That's what it means. Most of the World Series were played in about 6 games. All right, we also want to find the variance and the standard deviation. So I'm going to come back to my calculation. Remember, my standard deviation is going to be the sigma, right? It's the looks like a little 0 with a hat on it. So 0x, right, or sigma x is going to be 1.7 or 1.17? I don't remember. 1.17. So if I rounded to one decimal place, wouldn't it be about 1.2? Okay. So remember, this is kind of like my spread, right? What I mean by my spread is that on average, most games or most World Series last about 6 games. With most of them, right? So I'm going to do this number. Here's my 5.8, 1.2. So actually, if I take 5.8 and add 1.2, that's going to be 7. If I take 5.8 minus 1.2, that's going to be 4.6. Okay. So 34% fall here, 34% fall here. So most World Series, lasted about 6 games. And most of them had about a 1.2 spread. So what I mean by a spread is that most of the games might have lasted either 7 games, or maybe 4 games, or 5 games, right? But they were all in here, because this, if I were to round it, I might say 5 games, and that's 7 games. So most games lasted 6, and with or all games that had an average of 6, with most of them being either one more or one less. Okay, and then remember we want to find the variance. So the variance is just going to say let's take 1.2 and let's square that. Okay, so I'm going to come back here. I'm going to grab my calculator. I'm going to say, hey, what's 1.2 if we square it? And I'm coming up with 1.44, and that's going to be my variance. Okay. And that right there, guys, is 4.1.